In Chapter 13, we're going to be looking at what's called the normal distribution. So when we look at distributions, what we're trying to do is we're trying to take a set of observations and we're trying to get them to be described for a larger population. So typically we've got a sample and we want to know really what's going on with the whole population. And often we're going to start with a graph and go from there. So I'm going to show us a popular graph that we've been thinking about for a little while. And this was just the very beginning of COVID-19 spreading. And we saw with COVID-19, we hardly had any cases. And then all of a sudden it started exploding. In March and April, the cases were just increasing and increasing. Now we're starting to see places where it's increasing, some places where it's not increasing quite as quickly. And so we see a lot of variation there. But when we have been given these models that have told us that we expect a certain number of cases during this time period, so we can go into the different phases of reopening our country, how do they make those predictions? How do they know what's going to be happening in the future? Well, one of the things that they've used is how things have been modeled in other countries. And here in the beginning, we saw that China had a lot of cases, then it leveled off. And Italy, Iran, they were having a lot of problems with COVID-19 during March. And over the last few months, we've seen other countries having these same rises and declines and leveling off over time based on the different measures that have been happening. So we can take data from what's going on from other countries, but then what we can also do is we can fit some sort of model. And these mathematicians are able to create these very complicated models from the given data. We're going to be looking just at one very special model today, and in this class, we're not going to go into all of the different models. But what's helpful is when you can make one of these models, you can make predictions for future values. You can do a lot of different things that help us with making predictions. So this curve was shown to us back in March when everything shut down and we were just all at home, weren't supposed to go anywhere. And the reason that they told us that they wanted, they being these doctors, these epidemiologists, people who study diseases for a living, the concern was that if we don't slow down the case spreading of COVID-19, then we're going to overwhelm our hospitals. And at the beginning, at the pace we were going, the prediction was this blue graph where the number of people who got sick was going to go up really high beyond the number of hospital beds that we had to be able to treat people who were sick. So the goal of the shutting down the country was largely to keep that number of people infected at any given time to be under that threshold that we were able to treat the population who was sick. And a lot of the measures that we've taken allowed for this. In Virginia, we were able to keep the number of cases low enough so that for the most part, the hospitals were able to treat the people who were severely sick. And so by keeping that curve, they said flattening the curve, if you remember that, by flattening, it spread it out over a longer period of time, but it kept the hospitals, the medical professionals, to be able to treat the people who were sick. Versus if we had not done anything, the models predicted that we were going to have this sharp increase. A lot of people were going to get sick all at once, and then we wouldn't be able to treat everybody. So, what are these models? Why are they so important? And this goes back back into the 1800s when we were looking at using different displays of data. And William Playfair is one of the pioneers of this. And so far we've looked at these histograms where we have these rectangle bars. But how do we get a graph like the one here that was presented for flattening the curve? Well, we're going to use these different models, one of them being the normal distribution. So we're going to take our data and we're going to fit a smooth curve over it. You can see in this graph, looking at the number of text messages sent, most people send a small number of text messages a day, or maybe this is over a day, but there's some people who are just sending an obscene amount of text messages in a day. So we can create what's called a density curve, and we can take the data from our survey and we can fit this smooth curve. That's going to give us some more information for each of the different values. So instead of having a group from 0 to 100, now we can look at the frequencies for all of the different numbers. If we wanted 50 or 60 or 75, we can get some better information by having this more sophisticated graph. So the software is doing a lot of powerful calculations behind the scene, and we don't need to worry about where those calculations are coming from. We just need to learn what to do with them and how to make them useful for us to explain things going on. One thing to note is that software can often get little changes at the end, little ripples, little blips, if you will, on those curves. And it can do that better than a histogram will. However, sometimes software does have a little trouble getting the exact peak and getting the exact spread because it is trying to smooth these things out. So there's some limitations, but on the flip side, we get an awful lot of information from making these density curves. This density curve is getting much closer to what's called this normal distribution. And you can see here that it's relatively symmetric, relatively bell-shaped. It has a single peak, and this is data from 130 healthy adults. And we can imagine what the entire population would look like if we had everybody's information instead of just these 130 adults. And you get a curve that looks something like this in the figure. So what do we do with this normal curve? And we understand so much about this normal distribution that we're going to actually be able to make calculations from a normal distribution and answer some questions about probability using it. So in this chapter, we're going to learn about these properties of the normal curves. We're going to learn how to use them and how to think about them, and then also answer some questions about different distributions in ways that we might not be able to answer just from a histogram.